Welcome to lesson 3.2, graph linear equations. The first question we're going to be asked is which of these ordered pairs is a solution to this equation here? Well, for it to be a solution, that means when we plug in our x coordinate for x and our y coordinate for y, the equation will be true. So the easiest way to do this is plug in each one and see what happens. So let's go and plug in the 3 for x and the 4 for y and see what happens. So 3 times 3 is 9, minus 4 is 5. Does 5 equal 7? No, it does not. So that one does not work. Let's try the next one. 3 times 1 is 3. Ooh, let's just write that one out. So 3 times 1 is 3, minus negative 4. Well, minus a negative is the same as plus a positive, and 3 plus positive 4 is 7. So that one does work. We can try the next one. So 3 times 5 is 15, minus negative 3 would be the same as plus positive 3, which should get us up to 18, which is not 7. And we can try it with our last one too. So 3 times negative 1 is negative 3, minus negative 2 would be plus positive 2, which would come out to positive 1. Also still not 7. So this is the only one that actually worked. Let's try another question like this. Sometimes they might actually be asked to graph the equation. And we'll be doing a lot of graphing in this chapter as a whole. So one of the first and easier ways that you can graph an equation is to just find or make a table for your equation. What I will suggest doing is actually using a graphing calculator for this. But in order to use your graphing calculator, first you need to get it into the form of y equals something. So we need to go and rewrite this equation a little bit. So we have our y by itself here. So all we need to do to get y alone is we just have to add 2x to both sides. Because if we do that, we'll be left with a y equals negative 3 plus 2x. Or you might have also seen it as 2x plus negative 3. That would also be valid. Now let's go and plug this into a graphing calculator. So at our graphing calculator, we can start up going to this top left button to y equals, and now I just have to say what y equals, which in this case was that negative 3 plus 2x. Something I don't think I've mentioned so far is when you're doing negatives, you want to press this lower right button here right next to your decimal to do a negative. Doing minus 3 is going to tell your calculator that's supposed to subtract 3 from something, and if you didn't tell it what, it doesn't understand. So just go with the negative button is this one, which is different than your minus button. Anyways, back to the graph. So we've got negative 3 plus 2x. If you hit graph, it will graph that line, which is helpful if you want to just do a rough drawing because we know it's going to generally look like the graph that's there. However, that doesn't help you figure out what those points are. But if you go and press second and then graph, it will pull up a table. And now you can have some points for both x and y values to graph. So I'm just going to write these down quick. So our x values and our y values, they can go from negative 3 all the way up to positive 3. And if you want to see them go further, you could just use your down arrow to scroll further and it would keep giving you more points. But I'll just focus on that negative 3 to positive 3 because that makes it easier to graph. And we go from negative 9 and go up by 2s all the way up to positive 3. So that's always kind of interesting just to sort of recognize the pattern like that. So now I've got our points, so we'll go back to our graph and actually graph those points. So I copied those points over to the left side so I have something to work from. So we'll go from negative 3 down to negative 9, 7, 8, 9. And then negative 2 goes up to negative 7. The negative 1 goes up to negative 5. Then 0 goes up to negative 3. Then 1 goes up to negative 1. And 2 goes up to positive 1. And 3 goes up to positive 3. And since this one does not restrict our domain, now you can go ahead and connect those dots. And we know we've got a good line because we have our actual points that needed to be graphed. Something else that will show up in this equation is standard form. And standard form is just another way that you can write an equation of a line. So what it says is you have some number of x's plus some number of y's equals some number. And this is standard form of a line. So you could have like a 2x plus 3y equals 7. You could do 12x plus negative 3y equals 17. Whatever you want, it's just some number of x's plus some number of y's equals another number. It could even equal 0, and that would still be a valid way to write it in standard form. So you will be asked questions throughout the next few sections about different forms of lines. Standard form is just one of those forms. So let's go and graph a couple other lines. This first one, it wants you to graph y equals 2. Well, that's weird, because normally when you graph lines, there's both y's and x's. But when it's just y equals 2, well, let's think about it this way. Where does y equal 2, or where is the line that has a height of 2? Well, we know for sure that y equals 2 right here on our y-intercept. But it's not asking us to graph the point 0, 2. It wants us to graph the line y equals 2. Well, we also know that right here, it also will, over at 1 for x, it will still have a height of 2 right there. Or over here at -5, we'll also have a height of 2. So the line y equals 2 ends up being this horizontal line straight through at 2 for y. Now for the next one, x equals 1, you might be thinking, oh, well, if y is horizontal, if it's just x, it's not going to be horizontal, it's probably going to be vertical. So we know that our x value has a value of -1 right here on the x-axis. But right here, it also still has an x value of -1. Or all the way down here still has an x value of -1. So x equals -1 will actually be the vertical line passing through all the points when x is equal to -1. I will warn you ahead of time, this is something that students always forget. It's something that slips their mind, and it's going to keep coming up. Last year for me, it came up, I think, on 3 or 4 tests in a row. I gave students a question on this, and they kept forgetting what the answer was. So remember that. There are going to be questions on this, and you need to remember which are your y equals equations and which are your x equals equations. And those are your equations for horizontal and vertical lines. Now, to graph this equation, so we need to graph the function y equals -1/2 x plus 4 with the domain of x is greater than 0. Well, what that domain does is that restricts what values of x work for our equation. So instead of all positive and negative values, we're going to have to erase that line, and instead, we're only looking for positive values of x. So that means it's only going to be on this side. Now at this point, we just need to graph this line. And so we could go and use our graphing calculator for this, or since it's a line, we know that if you connect 2 points on a line, you can connect the dots and you've got your straight line. So let's just find a couple points. We can plug in values for x and see what happens. So I'm going to go and make a table for x and y. And we know that our minimum value for x is 0. So let's make sure we go and plug in 0 as one of those values. And let's try 2. That's another good value. So if we plug in a 0 for x, 1/2 times 0 is 0, plus 4 is 4. We can also then plug in 2. -1/2 times 2 is going to give you a -1, plus 4 is going to give you a positive 3. So now we can just graph those points. So at 0, we go up 4. Whoops, there we go. Up 4, plot that point. And we know that at 2, we're going to go up 3 and plot that point. Now we can go ahead and connect our dots, continue our line, just make sure we draw that arrow. Since our domain is restricted up here, we don't draw an arrow in both directions. We're only drawing our arrow going to the right. And that's because going to the left is cut out because we restricted our domain. The other part is it wants us to identify the range, or what y values work. Well, we can see from our equation that the largest y value is going to be right here at 0, 4. So that means all of our y values have to be less than or equal to 4. They can't be bigger than 4 because that'd mean going to the left, and those domain values don't exist. So we can only go with the domain we have, which means that our range has to be less than or equal to 4. Ooh, okay. So we've got a runner who is out running, like runners do. And the distance that they've traveled is modeled by this equation. Distance is equals to 6 times t for time, or how many hours they ran. If the runner then runs for 1.5 hours, we need to graph a function and identify the domain and range. Well, what we mean in this case is when you're graphing where they are at all the different times from when they start until they run for 1.5 hours. So let's go and just plug in some numbers. That would be helpful. So at time and distance. So at time 0, 6 times 0 is 0. So that means we have a point at 0, 0. At time 1, 6 times 1 is 6. So at 1, we'll have run a distance of 1, 2, 3, 4, 5, 6. And at 1.5, 6 times 1.5 is 9. So if here's 2, there's 1.5 coming on up. So there's 6, 7, 8, 9. So now we can go ahead and connect our dots, and we have a drawing of, or a graph of our function. Now, if we have to identify our domain and range, the domain is just what x values go in, or in this case, what time values work. Well, our time can be anywhere from 0 up until 1.5. So that can be your domain. Your range, then, is what y values work. Well, your y values go from 0 up to a distance of 9. And that's all the more there is to this one. Ooh. What if, however, a runner wanted to run 12 miles instead? Well, that's now asking about, we have a set distance and we want to solve for the amount of time. Well, so in that case, all we know then is 12 equals 6 times time. We could divide both sides by 6 to get time by itself, and we're going to come out with t equals 2. So the only thing that would change is we would then go all the way up to an x value of 2 if we had to graph this, and it would go up to 9, 10, 11, 12, and we could then continue up going higher. Or for our range and domain, it would change from 1.5 and 9 to a time of 2 and a distance of 12. That's all the more there is to this one. So give your homework a try, and as always, if you have any questions, send me an email. Good luck.